So thanks, Alina. Yeah, I'm being heckled by the technology. That seems appropriate. So I'm very flattered to be here and be hosted by Digital Futures. I'm a scholar in residence, and I think this is a really outstanding program. I mean, most of the time it's just the scholars in residence in this building, but we had a lot of good chats, especially over in KTH, and the group over there have been fantastic to me. There's a QR code if you want to go to my group's pages. That'll appear at the end as well. So maybe wait and see whether the talk was any good, and then decide whether to go and read the papers. That's my email address, and that's my Twitter handle, which I use when I can stomach all the climate woe. So I should be honest about the talk, right? It's a talk in 3 parts. It probably has a bit of let's get some perspective that might be for some old news and some new news. Then it has a bit of kind of reflection in the middle. And then I finish with some thoughts at the end about the role of ICT in helping save the world. Distinguished lecture, I think that just means people who are quite grey in the hair, maybe. We shall see. So let me start with the easy stuff. Where on earth is Lancaster anyway? So there's a country over here that used to be part of Europe. This is the border with Scotland, and Lancaster is over on the west coast in the north near the Lake District, which if you're visiting, do stop by. Absolutely beautiful place, lots of lakes, and it's not quite as flat as around here. We have some hills to walk and some cycling to do. And Stockholm's over here, so it's quite a long way. And if you buy me a beer, I'll tell you about my train journey to get here. My group, I'd just like to acknowledge all the work I'm going to reference is pretty much done with my group. Matt, Christina, Ali, Caroline, Kelly, Christian, and Iman, Oliver, Adam, and Janine, who's still in sociology at Lancaster now. And what do I do? What does the group do? Well, we're kind of interested in what technology can do as a sort of scientific lens onto everyday life. So let me give you some examples from some past work. This was some work from 2009, which was basically commenting on the energy situation on the remote island of Tiree, where they had a community wind turbine. And what we wanted to do was see, instead of thinking about using energy when you wanted to, we wanted to respond to the changing availability of renewable energy. And I think this is a topic that doesn't get enough attention even today. So this was a device we, in a workshop we did with small children, sort of prospecting for PV and wind, and mapping it. And this was an in-home energy display, which was talking about the availability of renewable energy. And I can't tell Swedes anything about this because you can just buy a time of use tariff and you're at least 10 years ahead of the UK. And that's a whole nother story. We've done lots of studies of student life. So this was from a sequence of materials that came from a project which was talking about thermal comfort and food and this sort of thing. And I had a designer come up with these nice things to try and get people to put the layer on instead of turn the heating up. This is from an ongoing study of thermal comfort, which is looking at radiant versus ambient heating. And we've got these sensors around our lab back home. And this was from a study of diet, and specifically direct energy in cooking against embodied footprint of menus. So that's sort of what the group does. We look at different aspects of everyday life and we say, what's the role of digital systems in shaping that? Because digital systems shape our lives. How many people have a phone in their pocket? How many people use it to shop, book transport, look at the weather? You know, our lives are configured through digital technology. And so I think technology then has a role in helping shape the impact on society and on the planet. Anyway, what am I going to talk about? Some motivation. I'm going to talk about a piece of work we did looking at ICT's carbon impacts, and there's various assessments of this. And then I'm going to try and pull out the sort of narratives that they're using to talk about whether we should worry about it. Does ICT have an impact we should care about? Should we do anything about it? Or are the drivers of ICT, Moore's law and so on taking us in a direction that means it's actually not an issue? And it's quite controversial. I was a bit worried that some of the authors of some of the reports we reviewed might dial in because they're in Sweden, but they're not here, so I'm going to carry on. So I hope it goes without saying that there's quite a lot of people on the planet, and that our actions are very much associated with impacts on the planet and the biosphere. Does anyone not agree with that assertion? Good. Definitely in Sweden. Could give this talk to the City of London, probably get a punch in the face. And we're in what we call the Anthropocene. So we create infrastructures to move goods and materials around. And the thing that brings all these things together is they're all interfaced with digital systems now. They track things, they interface things, they allow us to build supply chains and extract things efficiently, which all has a big impact in various ways. Now, a lot of us are probably feeling a bit guilty about climate change, especially when you have climate strikes and people saying, quite rightly, the system's broken, we need to do something, and it's your fault, older generation. Yes, you, distinguished Professor Friday, I'm not distinguished professor, distinguished lecturer, professor. Your generation did this. That's not really true, right? This is a problem a couple of centuries in the making, born in industrialization, and essentially digging up of fossil fuels, which enabled us to power that. So this shape, it should be kind of familiar. So from a couple of hundred years ago, we've managed to population has managed to grow because we've had energy to colonize and expand. We've got foreign investment, water use has gone up, not surprisingly, in population. And the impacts on the planet, if we think about that, are doing the same. Correlation or causation, it follows the same shape. We've got ocean acidification, carbon dioxide levels, which gets a lot of attention. And especially when we talk about the impacts of ICT, this is where we tend to focus. But there's all this other stuff we might want to think about and the interrelationship between those things. And I suppose to put this in perspective, you often get discourses of delay saying, well, the climate varies, it's ice ages, blah, blah, blah. Over the last 100,000 years, the climate has varied a lot more. And actually, all of what we know of as civilization fits in this last 10,000 years. And that expansion has happened kind of here in this very last hockey stick at the end. So I think it's important to stay within this band. I hope you agree with me. And I think, I'd go as far as say our very survival depends on it. And this is an old diagram. Many of you will know this. Rockström in the famous work talks about these 9 planetary boundaries and how where we really want to be is in here. And we want to think about our impact in biodiversity loss and flows of nutrients into the sea and various other things, acidification of the oceans. So that's the big picture thing. Can we start to think more holistically about the impact we're having and ICT's role in that? But there's a bit of a problem with technology, I think. It's all very clean, isn't it? It's all very nice and it's glass and it's smooth and its sort of impact on the world in terms of the resources, the extraction of the minerals, the energy it's using, carbon footprint when it's built and runs and is disposed of and maybe recycled. That's all sort of very hidden. So what we tend to think of is that ICT and computation is free, but it does have an energy cost and it does have an environmental cost. And Priest set out talk about the cornucopian paradigm. So this is things like the all-you-can-eat data tariff on your mobile phone. Download as much as you want, right? Like that's a free thing. It's not really a free thing, but we're just used to designing for the fact that capacities are growing, CPUs are getting faster, networks are getting faster, coverage is getting more pervasive. So we're used to designing for this embarrassment of riches, but I think that has to stop. So how significant is ICT? These numbers are probably out of date, so I'm sure you can correct me. If we think about energy demand, global ICT, and this is a massive, it's everywhere, right? It's a very hard thing to conceptualize and manage, is estimated to use about 4 gigawatt hours by 2030. And to put that into perspective, that's sort of roughly North America in terms of energy demand. That's a whole heap of energy. And then I know this will be out of date because for quite a while now, renewables has been the cheapest way to generate electricity. So there's been a lot of investment. But back a couple of years ago, we're only generating, a few orders of magnitude of that in terms of renewable capacity. So if we are going to green energy use in ICT, we have a bit of a mismatch to deal with. The bit I'm going to talk about now is work with some other colleagues, Brian Gordon and especially Charlie and Mike Berners-Lee from Small World Consulting. They're sort of life cycle accountant specialists, and they have their own methodology, and they've done a lot of work with big corporates on their carbon footprint. I don't think I'm allowed to mention who they are, but they're big. And we collaborated on a report that went into another report I'm going to mention later on. It's called The Real Climate and Transformative Impact of ICT, a critique of estimates, trends and regulations, and Charlie Freitag, which is Friday in German. There are 2 Fridays on this paper. How cool is that? If you just Google impacts of ICT and patterns, you'll find it, or the DOI is there. If you're interested in the detail, obviously do look at the paper. But what did we do in that paper? So we tried to find the best estimates, the most respected estimates of ICT's carbon footprint globally. We then interviewed a bunch of the authors of those papers, Anders Andre, Jens Malmoden, I'm sure I pronounced his name wrong again, and Lofty Berkir. And obviously we worked with the company with their expertise as well, and we produced our report. Now it's worth saying that this is not an easy task, and my goal here is not to critique really their estimates or how accurate they are, because they did a better job than I could have done. But I want to look at the narratives they've used, and that's what I'm going to come back to. So just so we're on the same page, you probably all know this, but Scope 1 emissions are the emissions by an organisation, right? That's what the energy we're kind of using. And generally, it's quite hard to get this because it's quite sensitive, especially when you talk about data centres or networks. The companies don't want to give you that data. Then there's emissions from the generation of electricity itself. And an important thing to recognise is that this changes with time because the weather, renewables change with wind, they change with sun, so they have patterns. But society also has patterns, right? We have patterns of demand related to things like meal times and work hours and these kind of things. And you have to match those 2 things up. But that means when we do computation, it has an externality that varies, although we tend to use a constant for this, that's not really right. And it varies very much around the world. There's tax efficient places, which means people do a lot of compute, both where there's geothermal energy in Iceland, and it's very green, or where there's a lot of coal in India and China, where it's really, that same compute is much more carbon intensive. Is that okay so far? Yep. But the really hard one, the elephant in your room, if you like, is Scope 3. That's all your supply chain emissions, everything that's embodied in everything you use. And there's really a lack of disclosure about how quickly people upgrade data centers and what's driving the embodied footprint of organizations. And it's also the hardest to get to grips with. Whenever you talk to a company, or let's say someone said to you, what's the carbon footprint of your research project? That will be the one that would be the hardest to work out. Right? Where do you draw the boundaries? When have you got enough to be meaningful, and what do you leave in and out? So where are we? So these were estimates published for basically estimating a couple of years ago, really, because we tend to be working with historic data, that said we were about 1.8 to 2.8% of global emissions from ICT, right? Which is, does that sound like a lot? I think that's quite big. That's the global emissions to go at. And these little bars are, they mean different things, right? So there's user devices, data centers, networks, and whether or not they include things like TVs. So TVs historically were not smart devices. I challenge you now to buy a TV that hasn't got a computer in it, that's not a streaming receiver of network content, right? So do you include it or don't? It's one of these boundaries. Internet of Things, do you include it? I don't know. So there wasn't really as much agreement here, although we think Malmoden probably has the most recent data, but also works for a big company that needs this stuff to keep going. So draw your own conclusions. So the actual breakdown of this, and depending on where you focus, this is more or less easy to manage. Andrea and Adler think it's sort of roughly thirds. The data centers are about a third of the problem. The rest is sort of down to the devices that we're using. And at the other extreme, Malmodin would say the data centers are much less of a problem. And in many ways, data centers are the poster child of efficiency because you get to do compute at huge scale for the amount of cooling you're doing. And I know that is causing a lot of issues for people doing other types of computing as well. And we think they're underestimating, right? Because when you do life cycle analysis, you don't take into account all the infinite fractal implications of that. So there's a truncation error. So possibly, this is as much as aviation globally. And I think there's also a healthy dose of speculation about what the future adoption curve of emerging technologies like AI and deep learning and machine-to-machine communication, what those are going to be in predicting the future. It's a very hard problem. So I quite like some of these headlines. I'm just going to throw some headlines at you. Training a single AI model can emit as much carbon as 5 cars. I don't know whether that's true, but if you plot the size of NLP models, language models, deep learning stuff that's going on in the deep learning literature, there's pressure to get bigger, especially Alibaba, Facebook, Google. Their clusters are bigger and they get to push back on people whose clusters are too small. So there is certainly an arms race to build bigger models, and it takes much more energy. I think the Facebook cluster a couple of years ago, or a year ago, was 500 GPU nodes. This is a lot of energy, and they trade it for a month. Well, maybe that's hurting them a bit now, but they do have lots of money. Just one to twist the knife, because blockchain, Bitcoin, machine learning, it's everywhere. I don't know, I'd almost like to do a natural language analysis of all the research funded in the UK just to see how much of it. So I've even seen people do a project on energy trading, which is like high frequency trading using blockchain, which is like a totally mad, self-defeating. Anyway, so Mora published this paper saying, Bitcoin emissions alone could push us above 2 degrees. And then Massanet and Malmodin et al. Said, no, you're wrong, because people are adopting much more efficient mining kit and efficiency will win. And then Mora came back and said, oh, no, you don't. And really my goal is partly to surface this issue. Right. But the point I want to make with this is there are some pretty resource-intensive technologies here. They use energy, but there's also an arms race to do the proof of work, to do the next block in the chain, right? So the dominant cryptocurrencies are all using the proof of work algorithm, maybe 70% of them. And you have to keep upgrading your hardware to keep pace with the state of the art. Otherwise, you stop being the next one, right? So there's a embodied footprint brought about by the computational footprint. And that's another impact to think about. So I'd say the debate needs to be more than just operational energy. It's not just this focus on how much energy are you using to charge your phone. It's how are you generating that energy? What are you going to do at the end of life, and how soon will that end of life be specifically? And I think a thing we're not, these are scopes 1, 2, and 3, but I think there are other impacts of technology, mental health crises, resource exploitation of people mining the minerals, actually the fundamental amount of each mineral we have on the planet and whether we want to spend it all now or save some for future generations. I think there's some huge societal questions here. I hope I'm not depressing you too much. How long have I been going? Quite a long time, actually. Right, I'll maybe speed up. So one of the narratives then that comes out is we don't have to worry about ICT's footprint because of efficiency gains. I'll come back to that. But also that we're doing good. Every time you have a video conference, maybe you're not flying, there's a net gain in another domain, be it buildings or travel or somewhere else, which means we're doing okay. And particularly there's the Smarter 2030 report, which is quite detailed, but is a consortium of the tech industry. I'm not saying there's vested interests, just to be clear.
But you're thinking it.
I'm thinking it. But they're saying, you get it all, right? You get savings in other industries, you get efficiency improvements, you make profits, growth continues, impact reduces. I mean, it's a nice narrative, not one I happen to subscribe to. So anyway, let's turn to some of these narratives. I'm just going to work quickly through the for and against for these narratives. And I'll try and keep an eye on the time. So, there seems to be some evidence, particularly in data centers, that the efficiency, the amount of, especially Massenet's work, the amount of compute we're doing now is significantly more for not much more energy budget. Right? But will things like Moore's law, the continued integration of more and more transistors on processors, will that continue? There's also, there have been significant improvements in the performance of data centers to their cooling, their overall energy use, which is not surprising because there's very good cost reasons for driving that. And the data centers are getting bigger. They're getting sort of hyperscale, like cities. And there has been a shift away from some of the old TVs to more mobile device, media consumption, that kind of thing. But some of the people we interviewed were saying, well, I think we're starting to reach a limit. There's actually been a limit on sort of clock speed of CPUs since about 2004 because we can't drive them faster without them getting hotter. That's more energy to get rid of, more heat energy to get rid of. As they get more tightly compressed, closer together, you start to get quantum effects. So they've got very clever with sort of 3D geometries. But are we reaching the limits? They say we are kind of reaching the limits of Moore's law, although we're getting very creative with parallelism and various other things. And there are other technologies like nanophotonics and things which haven't yet delivered. So anyway, and even Massenet, who's quite optimistic about data centers, says we need policy to put a limit, because once you hit that limit, the energy demand will go up because you can't make the thing any smaller. So I've made this point before. The Massenet study in 2020 said that for about a modest gain in terawatt hours, they think that the data centers are doing roughly 5 times the number of compute instances. So that's good, I suppose. Oh, I can't see my slide in there. But I think there's an interesting networked effect here that when you do things like create the first 4K TV, then everyone gets rid of their old TVs. And then you increase the capacity of your network, which lets you create new digital services, which let you create new ways to consume that compute resource, that network bandwidth. And this is what's called a rebound effect. How many people have heard that term, rebound effect? Yeah, no points for you. So I'll just mention this because the first time I heard this, who's heard of Jevons paradox? Okay, quite a lot of people. So the first time I heard this, it absolutely blew me away. So hopefully you'll be as weirdly excited by this as me. So William Stanley Jevons was an economist and philosopher in the kind of 1900s. And he was studying the use of coal and economics in the Industrial Revolution. And there's this really, really interesting phenomenon. Yeah, thank you, Daniel. Did you see that? He said, I heard about Jevons paradox more than 100 years ago. Yes, but I'm more than 100, Daniel. No, that's not actually quite true. It's close to being true. By an order of anyway. So what he discovered was that the original steam engines were not, as you would expect, the early technology was not very efficient. Right? Need a lot of coal, very expensive to run, expensive big machines. But quickly the machines became more efficient and burnt less coal. And the perverse thing here is you'd expect the efficiency to drive a reduction in coal use. But actually it became much more cost effective to drive a steam engine because they were more efficient. So you had more of them. So although the engines were more efficient, you use more coal. The net effect was a growth. And I don't think it's been demonstrated in ICT yet, but I wouldn't be surprised if we can find examples of technology that instead of driving a reduction through efficiency gain, drives growth in footprint. Was that a surprise to anyone? It's just me, isn't it? It's just a surprise to me. Really, yeah.
So let's say at that time, having more steam engines would give you more overall output, more productiveness.
Yep.
It's not clear to me that having more computing centers gives you automatically more productive output. It might, just to say the extreme, give you more TV series that nobody needs and more spam mail.
What a lovely observation. So, so that comes to firstly an idea of exergy. So how much useful work do you do for your energy, which I think is fascinating. But also, what value do you place on it? So my kids get a lot of social value out of watching endless Netflix. But as their parent, I would say that has negligible value to their lives, right? So there's some really hard questions here, aren't there, about whether what we're doing is useful. And some of the economic drivers are around shifting video or internet gambling, or, I mean, you know, various other interesting things, cryptocurrencies.
I just, let's say my spam mail filters out, I don't know, way more stuff than I actually receive.
Yeah.
So whatever way you turn it, this would not be productive because I never get to see it.
Yeah, no, absolutely. But it's very cheap for them to send because they're not paying for their impacts. I think we reckon 80% of email is spam. And just think of the storage burden and the servers you're having to upgrade to keep this ever growing volume of nonsense. But yeah, okay, thanks for that then. So another argument that's made in some of these reports is that ICT's emissions will stabilize because there's only so much human attention. There's only so many people can have a phone. There's only so many people can be looking at their phone. You kind of get the argument. And that's some sort of, I mean, I think Cisco reckon that about 70% of the global population has a phone. But I think there's very strong commercial incentives to shift more devices, which I think I'm just going to have a quick look around, see how many displays I can see embedded in the room around me. And I think we're quite good at inventing other technologies that don't require direct human intention, you know, training AI models, Internet of Things. And there's a lot of people around the planet who don't enjoy the same access to technology. So I think there's a long way, personally, I think there's a long way to go before we hit saturation. I was on a call on Friday, which Alina knows really annoyed me, with a conference, and we're talking about, should we have a banner image on our website for the carbon footprint of the conference? And I thought this, my blood's boiling again. I think a really important thing is what we have seen is the ability to shift a lot of data for not much more energy footprint. So what seems to be happening is that most network and data center infrastructure are provisioned for peak load. So they're actually not very busy most of the time. And the real question is, how many users have you got? How much coverage have you got? How big is the infrastructure growing? And what are the drivers of that growth? But that actually means that there's you know, a relationship between, yes, there is energy used to ship video around the planet for all these services that keep popping up, but actually it's the drivers of the infrastructure growth that are leading to more. And then another controversial one then, is ICT enabling carbon savings in other industries? You know, are we flying less as a result of more video conferencing? Would be a classic example, as promised. And I think we would just say that global emissions are still climbing. So, and we've had digital technology, video conferencing for quite a while. So I'm going to suggest possibly no, and that ICT, as Priest was telling us, might be leading to rebound effects there. You know, more informal contact leading to more travel, maybe. And finally, my last piece of rhetoric. Is it not a problem because we're going to just use renewable energy for powering our IT, so it doesn't matter how much computation we do? Well, it's certainly, I mean, some predictions have said if we move all of global IT over, we'll save as much as 86% of its footprint, which is probably a bit high. It's certainly cheapest per gigawatt now to generate renewables, and a lot of big IT players have made commitments to offset and invest in renewables. But I don't think this is a silver bullet, because we also need renewables to do other things like heat our homes and power our vehicles and various other things. Do we want it all to be email spam or internet gambling, or would we like to use that renewable energy for other things? And I also think there's a resource question. You know, how much renewable technology can we create before we run out of resources? And I quite like, I mean, this is a figure from the report. I'd like you to imagine that the carbon footprint out to 2050, you know, we're meeting our Paris targets, and that ICT's footprint doesn't grow, which I think is a pretty best case thing. That's the orange line at the bottom. By the time we hit 2050, ICT is responsible for over a third of our emissions. So I think this means we need some governance back here, some target setting. No? Okay, I'm looking forward to the questions already. But I do see a lot of very careful boundary drawing, right? So here's one of my pet ones. So 5G communications technology, with a certain lens, it is clear that you shift more data per joule of energy. You know, if you think about the transmission power and the coding and so on. But there's no free lunch here. You have to have smaller cells, which means you need more of them. And you have to power more cells and build more infrastructure. But it's not, I mean, the thing they carefully admit, right, is it's not like 2G, 3G, and 4G went anywhere, because we've all got devices that are reliant on those. I mean, my smart meter in my cellar has a GPRS receiver, so you can't get rid of these. So you're just layering this on the top of those. You're not really getting a gain, you're getting a layering effect. So I think where people, you know, it's important to be really careful around these narratives, because where you draw the boundaries and how you present your argument colours the outcome of it. Worried about time, really. There aren't many more slides. And I think I'd just ask the question that if our carbon budgets are doing this, and our efficiency gains are making small changes, that's not going to be enough. So I clearly believe ICT's footprint is going to grow. I'll pin my colours to the mast there. Well, I think ICT efficiency gains have coincided with global emissions growth. I think there are growth trends that we're not managing, like the massive application of AI and machine learning to just about anything, Internet of Things, blockchain, and I think they will deliver efficiency benefits in many domains, don't get me wrong, but will there be a net gain or not? And there's huge investment behind these technologies to make them grow, which takes us to the sort of economic side of that. And I think the lack of oversight is a risk, really. And this is a bit of a silly example, but I hope it illustrates the point. ICT is also embedded, as I started with, you know, ICT is embedded in how we live our lives. And I click and I get a e-bike, and then I get to travel somewhere and use some energy to do it. If I have a self-driving car, you know, does that let me then create new journeys to take my dog to the vets without me, because I no longer need to drive them there? I mean, it's a kind of silly example, but I hope you understand that when we put new applications and services into society, we change society, and we may increase impacts or we might reduce impacts. That's not my dog, by the way. Just be clear. So I thought I'd finish on a sort of more speculative and optimistic note. Are you ready for more optimism? Excellent.
More optimism? What do you mean more?
Some optimism. Yeah. So I quite like this cartoon I found this morning. When I was a kid, we only had 332 million websites, and we had to wait a whole second to watch a YouTube video. You know, I think it's really interesting what we grow, right? And let's see. I think we can change infrastructure. The question is, can we change infrastructure for good, whatever that means? Does anyone know what that is? This is much better than online talks. You can actually look people in the eye, so they've got nowhere to hide.
Is it a toaster?
It's a toaster. I think it's from a museum in the UK. I don't know if it's the first toaster. I wouldn't like to say, but I quite like toast. technology writes our infrastructure. You know, that's true of micromobility solutions, it's true of solar panels, it's true of toasters. It changes what we do and how we do it. And social practice theoreticians in sociology, like Elizabeth Shove, would talk about how this has changed over time. And it changes, you know, in 1950s Britain, which is seeming alarmingly close these days. You know, the introduction of electricity, the introduction of central heating, it changed how we used our houses, it changed how we lived our lives, it changed what it meant to be comfortable, right? The toaster changed what we had for breakfast and the ability to produce hot bread, and it changed our diet. So I think technology, I think ICT changes our lives, it clearly does. And Yolanda Stringers talks about, it's not about giving people information, it's about the design of the more socio-technical systems that you're trying to achieve. So that's sort of worth a read. It's only a very short article. And what if we started with a more holistic big picture? I can't remember I do remember who I stole it off, but I don't remember where it comes from, which I apologize for. If you do the sustainability, the SDGs, Sustainable Development Goals, in this format, I think it makes a lot more sense. We depend on the planet and the biosphere for life, and we depend on society for survival as well. And then the economy is the last thing we should worry about, really. We should worry about this. But we can go this way. It's economy first, planet last, right? And that seems like it has to be doomed to failure. So the questions I'd ask, you know, should there be limits to ICT growth? How do we start to think as a discipline of design and technology and algorithms of a non-cornucopian paradigm? You know, how would we work within those limits? What do we prioritize? I thought I'd put digital futures in there to try and trick you. Can we design digital futures for system gains, for net gains, rather than just narrowly focusing on energy? Because if we just focus on energy and efficiency, we're going to lose out on these other things. And then I believe, I mean, this is not a very good example of that, I wish it were. This is taken from a project I did on last mile logistics on the City of London. And the red line is the delivery worker, the yellow line is an electric delivery vehicle. And what we noticed was essentially they walk as much as they drive. And while they're walking, they're parked and they're taking up a parking space. So actually, in terms of the utilization of the city, it's not very efficient, and this totally hidden activity of walking is really important to what they do. And you could maybe separate those things and have pavement porters and do that differently. It doesn't change the fact there's too many parcels or that kind of thing, but it does let you think differently about how that logistics operation might work. And I was involved with a working group with the Royal Society, which Andy Hopper chaired. He's the treasurer of the Royal Society in the UK, called Digital Technology and the Planet. And we've got a little report there, which you actually tinyurl.com RSDTAP, it says, under that thing, that just basically talks a little bit about the role as a sort of, I mean, he's an engineer, right? He wants a digital control loop. He wants to be able to manage things. But there's a big question there. What is the role of ICT in developing the insights we need for rapid decarbonisation? And our Kai paper last year, shameless plug, was all about, you know, how can HCI contribute to informing policy development around that, and, you know, have we taken on too much as a discipline and too many other sub-disciplines and so on. So, nice picture of Sweden, I'm sure you'll agree. I very much enjoyed my time here. I hope you know that we're facing something of a climate emergency, and I feeling pretty galvanised about doing something about it. Yep, I'm seeing nodding. That's good. I'll take that. ICT is driven by growth and efficiency paradigms with little transparency. There's some voluntary IETF targets, but not everyone's signed up to those. I think the switch to green energy and efficiency is a bit of a, I mean, it's a good thing, but it's a bit of a red herring. It's insufficient, and it's probably a high-risk strategy. And what I'm going to argue for is socially and environmentally responsible ICT design. So if you like the talk, There's a QR code to read the other papers. If you didn't like the talk, then there is not a QR code. And you can always email me or tweet me, I suppose, or actually I'm here till Monday, so you can speak to me as well. And if you're interested in HCI and Paris compliant design, my colleagues Kelly and Gordon have a new project on it. So a quick plug for them, Paris DE project. And with that, I will take some questions if there are any.